Hi folks, this is question 2 from the November 28th homework sheet. Okay, so they're asking us to solve this equation and they're giving us a domain of values that we're interested in, so from negative 2 pi to pi. So again, when you look at a question like this, I hope that you would recognize that it looks a lot like a quadratic trigonometric equation, with the issue being that the trig ratios are not the same. Okay, so the idea here is, can we rewrite this so it's got all the same trig ratios? And at this point, one of the most common identities we've used has been the Pythagorean one. So I'm going to use the Pythagorean identity to change this sine squared into a cos squared, so that it'll hopefully line up well with that cos x that I've already got. Okay, so step 1 is to change sine squared into 1 minus cos squared x. Okay. Now make sure you're being very careful when you're doing the algebra when using and when rearranging these trig identities. Okay, so minus 5 cos x minus 2 equals 0. And so now I end up with a quadratic trigonometric equation, this time in terms of cosine. Okay, so let's just simplify first. So 6 minus 6 cos x squared, cos squared x minus 5 cos x minus 2. Now again, I would rather work with the positive leading coefficient, so I'll move everything to the right side. So 0 equals, this becomes positive cos squared x. This is going to be plus 5 cos x, and 6 minus 2 is 4. When I bring that to the other side, of course, will become minus 4. Okay, so now here I've got to factor this out. So I don't have prime numbers here, doesn't matter, so use whatever factoring method you have. So here I'm going to use, say, start with 2 and 3 for 6 and 2 and 2 for 4, and when I check my possible multiplications, 4 and 6 won't lead to 5. Well, 4 and 6 the same, still won't lead to 5, so that one doesn't work. So let me change the 4 to 1 and 4. Okay, and so here I've got 2 and 12, that won't work. Here I've got 8 and 3. That will work, because with 8 and 3 I will be able to get to 5. Okay, so what does that mean? That means that my 6 cos x squared will be written as 2 cos x and 3 cos x, and my 4 will be 1 and 4, but I have to multiply the 2 to the 4, so that's going to go here, and the 1 times the 3, so the 1 will go there, and I need plus 8 minus 3. So plus 8 minus 3, and there we go. Okay, so now we have things in factored form, which is what we want. So now we can say that either one of these can be equal to 0. So that means that cos x must either be equal to 1/2, or cos x must be equal to negative 4 over 3 when I solve that out. Okay. I see here that this is less than negative 1, so I know cosine can't have any values less than negative 1. So I'm going to, make sure that I show that this is a possible solution, then indicate somehow that there's no answers that follow from it. So I'm just left with cos x equal to 1/2, and of course, since I know this corresponds to special angles, I'm going to give exact answers. Okay, so let's see what kind of angle gives me a cosine of 1/2. So I know it'll either be pi over 6 or pi over 3. So here the x value needs to be the smaller one. Okay, so it's going to be pi over 3. Okay, the larger angled one. So pi over 3 will be one of my answers. Okay. Now the problem with using inverse cosine is that it's not going to give me an exact answer. Okay, so you have to have knowledge of your special angles. Okay, now there's two ways in which I can find my alternate answer. One is to just, know how special angles work. I know it's going to be in the fourth quadrant. Okay, otherwise I can use my related angle identity, 2 pi minus pi over 3. And lo and behold, 6 pi over 3 minus 1 pi over 3, 5 pi over 3, which of course is in the fourth quadrant. So however you find this second answer, doesn't matter as long as you find it. Okay, so here we've got 5 pi over 3. Now, right away, I notice that 5 pi over 3 doesn't fit within my accepted range of values. So I know I'm going to be not including it, but I still might be using this to determine other answers. So now, how do I determine my other answers? By adding or subtracting 2 pi. Okay, why? Because I'm working with cosine of x. No vertical, no horizontal stretches. So what am I looking for? Okay, losing my mind here. Period is just equal to 2 pi. Sorry about that. Okay, so pi over 3. Obviously, I'm not going to bother adding 2 pi because I have to stay less than pi. But let me subtract 2 pi. So instead of thinking of subtracting 2 pi, I'm going to think of subtracting 6 pi over 3. So pi over 3 minus 6 pi over 3 gives me negative 5 pi over 3. Okay, so that's there, still within my range. Okay, or of course, I can subtract 5 pi over 3 minus 6 pi over 3 is negative pi over 3. Okay, and here I can clearly see that if I start subtracting 2 pi again on any of these, I'll be going to a number that's less than negative 2 pi. So these are all my answers here. X can be equal to negative 5 pi over 3, negative pi over 3, and positive pi over 3. Okay, so just to recap, step number 1 is I have to try to isolate my trig ratio. In this case here, that took quite a bit of work. Number 1 was to realize that I needed to use my Pythagorean identity to get all the same trig ratio. Number 2, recognize it as a quadratic trigonometric equation, so get it in the right form, factor, solve. Okay, now that I have my isolated trig ratio, determine my 2 possible answers. Okay, in this case here, x didn't need to be solved for, it was already isolated, and use the period, in this case here 2 pi, to determine all the possible answers which land in my